Journey back over 1 billion years to witness the rise of multicellular life. In ancient oceans, simple organisms formed as cells began working together. This key moment in evolution allowed life to become more complex, shaping the future of Earth's biodiversity. Primitive cells banded together, taking on specialized roles. Some absorbed nutrients while others provided support, improving survival. Over time, these adaptations refined efficiency, laying the foundation for complex life. This key shift set evolution on a new path. In a shallow prehistoric sea, single cells formed loose colonies on the ocean floor. Some developed tiny hair-like structures to capture nutrients, while others reinforced protective layers. These adaptations improved survival and efficiency, fostering early biological cooperation. Within these colonies, cells show greater specialization. Some elongate to enhance nutrient absorption, while others build structural support. As cooperation improves, resources are shared more efficiently, strengthening survival and making life more adaptable to change. With time, colonies strengthened their internal connections, enhancing resource distribution and simple communication. This structured cooperation helped early organisms maintain cohesion, enabling them to thrive even as oceanic conditions fluctuated around them. Some cells specialized in absorbing nutrients, while others built protective layers, reinforcing stability. As interactions became more efficient, resource sharing strengthened survival. These evolving networks laid the groundwork for increasingly complex life forms. Microscopic world unfolds as cells arrange into simple tissues. Some elongate into structured formations, while others interconnect to provide support. Surrounded by dense organic matter, these primitive structures represent the first steps toward complex multicellular life. Early colonies exhibit increasing complexity, with cells organizing into layered structures. Some begin forming connections, transmitting signals that regulate growth. This enhanced coordination allows colonies to expand, adapting to shifts in their prehistoric aquatic world. In a shallow marine world, soft-bodied organisms resembling sponges and algae thrive. Drifting in nutrient-rich waters, they absorb resources directly from their surroundings. These life forms spread across the seafloor, forming dense clusters in the calm, prehistoric ocean. A closer view of a single, soft-bodied multicellular organism akin to a primitive sponge situated in nutrient-rich waters. The organism's surface shows simple textures and pores, absorbing resources directly from the surrounding water in a calm, prehistoric ocean. Vast ancient ocean floor is teeming with primitive life. Multicellular organisms resembling algae and sponges spread across the seabed. Some attach to rocks, while others drift with the currents. Dense clusters form in nutrient-rich waters, shaping the prehistoric seascape. Over 1 billion years ago, in ancient seas, clusters of primitive multicellular life appear. Some cells form thin filaments to connect, showing early cooperation. Swirling nutrient-rich currents help distribute resources, supporting their survival and gradual evolution. Inside a growing multicellular organism, cells exchange chemical signals. Glowing particles move between them, triggering coordinated responses. These signals regulate internal functions, ensuring stability and efficient interaction within the organism's structure. A cross-section of an early multicellular organism shows the distribution of nutrients. Nutrient channels are visible, with small particles moving along them. This efficient distribution system supports the organism's survival in a dynamic prehistoric ocean environment. In nutrient-rich shallow seas, soft-bodied multicellular organisms populate the water. Some drift freely, while others cling to submerged surfaces. Thick algal mats spread across the seabed, covering rocks and sediments, shaping the structure of this marine habitat. Along an ancient coastline, primitive multicellular life clings to rocky surfaces. Algal colonies thrive in tidal pools, enduring the ebb and flow of waves. This dynamic environment challenges early organisms, pushing them to adapt and survive in ever-changing conditions. A vast marine ecosystem flourishes as early multicellular organisms form colonies on the ocean floor. Diverse species interact, each adapting to its role. With stable conditions and steady nutrients, these life forms thrive, shaping the foundations of complex ecosystems. Thank you for watching. Creating high-quality content takes a lot of time and effort, from research to production. If you enjoyed this episode, please like the video and subscribe to support the channel. Your engagement helps us continue making great content. Stay curious and see you in the next episode.